Hello dear students, welcome back to my new video. Today my topic is combination. That is from the chapter 7 of ncert class 11, permutation and combination. We have finished the section permutation and its examples, theorems related to the permutation and derivation of the formula NPR in previous videos. Today we can discuss combination and theorem related to the combination and some examples. Okay, let's start. Okay, we can look what combination is. Combination is actually the selection of a part of a set of objects or selection of all objects when the order doesn't matter. Okay, we can define combination as a selection of part of a set of objects or a selection of all objects when the order doesn't matter. For example, consider a group of 3 tennis players X, Y and Z. A team consisting of 2 players is to be formed. In how many ways we can do so? Is the team of X and Y different from the team of Y and X? No, because here order is not important. In fact, there are only 3 possible ways in which team could be considered. That is, we can make team XY, YZ and ZX because order is not important. So we can make 3 teams using XYZ or XY, YZ and ZX. That is the combination of each tennis players. Therefore, the number of combination of n objects taken R at a time is given by ncr equal to n into n minus 1 into n minus 2 into etc. into n minus r plus 1 whole divided by r factorial, which is equal to n factorial divided by r factorial into n minus r factorial, which is equal to npr divided by r factorial. That is, we can get ncr equal to npr by r factorial. Next, we have to discuss the relation between permutation and combination. For describing the relation between these two, we have 2 theorems. One, theorem 5, that the fourth theorem is discussed in permutation section, and this theorem is theorem 5. Theorem 5 says that NPR equal to NCR into R factorial, where 0 less than R less than or equal to N. The proof of this theorem, corresponding to each combination of NCR, we have R factorial permutation because R objects in every combination can be rearranged in R factorial ways. Hence, the total number of permutation of n different things taken R at a time is NCR into R factorial. On other hand, we can write is equal to NPR. Thus, we can write NPR equal to NCR into R factorial, where 0 less than R less than or equal to N. We have some properties for combination, that is, from above we can write n factorial divided by n minus R factorial equal to NCR into R factorial, which can be written as n factorial divided by R factorial into n minus R factorial. That is, in particular, if R equal to n, then NCn equal to n factorial divided by n factorial into 0 factorial, which is equal to 1. That is, we write NPR equal to n factorial divided by n minus R factorial, which is equal to NCR into R factorial. We write NCR into R factorial as n factorial divided by R factorial into n minus R factorial. So, if we take R equal to n, then NCn equal to n factorial by n factorial, which is equal to 1. Second property, NC0 equal to 1. That is, the number of combination of n different things taken, nothing at all is considered to be 1. Second property says that NC0 equal to 1. And third property says that as n factorial divided by 0 factorial into n minus 0 factorial equal to 1, which is equal to NC0. Then the formula NCR equal to n factorial divided by R factorial into n minus R factorial is applicable for R equal to 0 also. Hence, NCR equal to n factorial divided by R factorial into n minus R factorial, where 0 less than or equal to R less than or equal to n. That is, in previous explanation we wrote NCR equal to n factorial by R factorial into n minus R factorial, where 0 less than R less than or equal to n. Here we can prove that when R equal to 0, the formula become n factorial by 0 factorial into n minus 0 factorial, which is equal to 1, which is equal to NC0. Therefore, we can write combination formula NCR equal to n factorial by R factorial into n minus R factorial, where 0 less than or equal to R, that is, R can be 0 less than or equal to n. Fourth property, NC n minus R equal to n factorial divided by n minus R factorial into n minus of n minus R factorial, which is equal to n factorial by n minus R factorial into R factorial, which is also equal to NCR. That is, selecting R objects out of n object is same as rejecting n minus R object. that is NC n minus R equal to NCR. Then fifth property, NC A equal to NCB, which implies A equal to B, or A equal to N minus B, that is N equal to A plus B. Next, second relation between permutation and combination, that is theorem 6. Theorem 6 says that NCR plus NCR minus 1 equal to N plus 1 CR. We have to prove this theorem. Proof. We are given NCR plus NCR minus 1, which is equal to, we can write NCR equal to N factorial divided by R factorial into N minus R factorial, plus NCR minus 1 equal to N factorial by R minus 1 factorial into N minus of R minus 1 factorial, which is equal to N factorial by R factorial into N minus R factorial plus N factorial by R minus 1 factorial into N minus R plus 1 factorial, which is equal to N factorial by R factorial can be written as R into R minus 1 factorial into N minus R factorial plus N factorial divided by R minus 1 factorial into N minus R plus 1 into N minus R factorial, which is equal to N factorial divided by R minus 1 factorial into N minus R factorial is taken outside. The remaining is 1 by R plus 1 by N minus R plus 1, which can be written as N factorial by R minus 1 factorial into N minus R factorial into, we can take LCM, then N minus R plus 1 plus R divided by R into N minus R plus 1, which is equal to N plus 1 factorial divided by R factorial into N plus 1 minus R factorial, which is equal to N plus 1 CR. Hence the theorem is proved, that is NCR plus NCR minus 1 equal to N plus 1 CR. Next we can discuss one problem. If NC9 equal to NC8, then find NC17. Solution. We have NC9 equal to NC8, that is N factorial divided by 9 factorial into n minus 9 factorial equal to n factorial divided by 8 factorial into n minus 8 factorial, or 1 by 9 equal to 1 by n minus 8. That is, we cancel the all common terms, we get 1 by 9 equal to 1 by n minus 8, or n minus 8 equal to 9, or n equal to 17. Therefore, we can write NC17 equal to 17C17, which is equal to 1.